Dear students, good evening. Today, let us see the most important problem from the Fem. This is the truss important problem. See, here the red color indicates the given problem 500 mm, 400 mm, and 300 mm. Okay, and they're given the this is element 1, this is element 2. Actually, they are given only nodes node 1, node 2, node 3. So, you are taking this one as a element 1 and this one as a element 2. Okay, here they are given the 12 kilometers load and they are given the Young's model as 70 gigapascal and the area 200 mm square. We are converted into 70 into 10 power 9 Newton per meter square, area into Newton per meter square. Okay, here they are given the length 500 mm, we are converted into 0.5 meters. Okay, so here we are divided this stress into, for example, this is the node 1. So as you know, there are displacements in x and y direction. So for each node, there are two directions. So q1 and q2, these are two displacements. Here also per node 2, 3 and 4, and for 3, 5 and 6. Okay, here the load is acting in downward direction. That is indicates the positive direction. If it is upward, you can take the positive direction. So for downward, you can negative. For upward, you can take the positive direction. Okay. So here we are to make it into in a rectangle section. Here 300. This is also 300. This is 500. This is also 500. So initially we are taken this as a 0 reference. Okay, we are extended this one. This is 500 and here this is given 400. 500 plus 400 900. So this is the x value 900 and y value 0. So 900 comes 0. And here see this is 0 0. This is the height to 300 300. So you can write this one as a 0 comma 300. After then this is see at this point this is 500 500 and this is height 300. So you can take it as a 500 and 300. Okay, now let us come here. This is the node 1. So x1 y1. This is node 2. So x2 y2. Node 3. So x3 y3. Okay, so this is about this figure. Then you have to find the elemental lengths, that is L1 and L2. So yeah, actually they are given directly a L value, so no need to calculate. But in general, the formula is x1 minus x2 whole square plus y1 minus y2 whole square. This is root. Okay, so here you can take here direct values are there, so you can directly substitute and you will get the answers. So 500. Similarly, for L2 also x3 minus x1, you can take the positive difference. 1 minus 2 1 minus 2 3 minus 1 3 minus 1. Okay, so finally got the 500. You can easily understand these values. Okay, so here also you can here no need to calculate, you can take direct value 500, but here you can calculate here. So you can also take this is 3 and 4. So you know Pythagoras Siddhantam 500, like that also you can take directly. Okay, right. After that you have to find out the, as you know here in the formula, this is the elementary stiffness matrix L square Lm minus L square Lm Lm m square minus Lm m square. See here L square Lm, here minus L square minus Lm, then Lm and m square. So minus Lm minus m square. Then you have to add minus for this first row. So minus L square minus Lm plus L square plus Lm. The next row you have to add minus to these values. So minus Lm minus m square minus Lm. So this plus m, this minus m square, this will be plus m square. So like that you can easily remember this formula, right? Then so here you need L square and Lm values, L and m values. So that's why we are taking formula delta x by Le, here delta y by Le. So that's why we take it as a difference x1 minus x2. So here also you have to take y1 minus y2, 1 minus 2 1 minus 2 only. So you have direct values, so you can substitute, you will get the L value, here m value. Similarly this is for element 1, this is for element 1. Similarly for element 2 we have formula. So here element 2 is in between 1 and 3. So that's why 3 minus 1, 3 minus 1, 3 minus 1, direct values you can substitute, then you will get the L value and m value. Okay, this is about the element table. You can calculate as a element table. Element 1, element 2, nodes, one element in between 1 and 2, and element 2 in between 1 and 3. So then you need to find out L and m values. Already you got L and m values. L value 1 0 and here 0.8 minus 0.6. Okay, then Lm, L into M. Here also L into M, and L square, L into L, M square, M into, like that. Then last you need, in the here you need A1 E1 by L1. Okay, so here you know the area E and L values, so you substitute directly, you got AE by L. Then here element 1 indicates, see, element 1 indicate in between 1 and 2. Here 1 means Q1 and Q2, and 2 is 3 and 4. So 1 2 to 3 to 4. Similarly 2 1 to 3. So 1 means 1 to, this is 5 6. So 1 to 5 6. These are the displacements. Okay, come to the element space matrix. Here already find the A1 even by L1 direct value. See this one. This is the value, you know, A, E, L values. Here both are same 0.5. So you got this value, and L square LM from the table you can substitute directly. So as I told earlier, element 1, so in between 1 to 3 so 1 2 3 4 1 2 3 4. Similarly 2 is the in between 1 to 5 6 1 to 5 6 1 to 5 6. Yeah, so this is similar to bar problem. So like so 1 2 5 6 1 to 5 6, same similar formula. Okay, so yeah, now next step you have to add the k1 and k2, you will get the global stiffness matrix, right? So 1 2 3 4 5 6, we are 1 2 3 4 5 6. So this is the 1 2 3 4 5 6. So like that you have to add this elemental matrices. So like that you will get, like, you know, the process, same process, similar process to the bar element, you can add easily. Okay, 0.64. So 1 by 1, 2 by 1, here 1 2 3 4 5 6, then 3 by 1, you can understand very easily. Okay, so like that you have to add all the values, right? Then if you observe this figure here node 1 is having some load, but here node 3 and node 2 both are having some fixed support. So that means q5 q6 will be 0. Similarly here node 2 3 4 and 4 0. So you taken 3 4 5 6 is 0. Still then you have to find q1 and q2 only you have to find, right? So that's why I have cancelled 3 4 5 6 rows and columns. Then we have only 1 2 1 2. So I taken 1 2, this is 1, this is 2, this is 1, this is 2. So yeah, as you in general, so is 1 2 3 4 5 6 means you will have q1 q2 q3 q4 q5 q6. That is the displacement matrix. But here you cancel all the values, that's why I have taken only q1 and q2, corresponding q1 corresponding q2, right? K, as you know, the formula is kq is equal to f. Yeah, the formula is kq is equal to f. Okay, so in this, from this formula, k q f, here f is here only load is there. So in this direction, with respect to q2 we have 12 kilonewtons, but this downward direction means negative. Then with respect to q1 there is no load, so in place of q1, similar to q1, 0 load. Here downward direction newtons, right? So after solve with simple calculator you can solve this one, then you will get the q1 and q2 values in meters. Okay, in this question actually they asked about the find out the displacements, stresses and reaction forces, okay, from the problem. So you already find the q1 and q2 displacements. Then stress, you have a formula sigma 13 is equal to basic formula E by L2 minus L minus M Lm. So Q1 3 5 6 1 2, because here 1 2 3 means in between 1 to 5 6 nodes, 1 to 5 6. So you know 1 to 5 6 values, you know Lm values, you know E and L2 values, you will get the direct stress value, that is 100 minus 100. Similarly if you want to find the stress sigma 1 2, that means per element 1. So similar formula E by L1 minus similar here Q1, Q2, Q3, Q4, because 1 2 3 4. Similar formula, you will get the stress minus 80. Like that you have to find. Then last they are asking about the reaction forces. So here at fixed supports we will have reaction. Here 3 4 and 5 6 we will have some reaction forces. That means you have to find out R3, R4 and R5, R6, right? Let us take the R3 formula. Here it is similar to bar element. So K31, 32, 33, 34, 35, 36. And Q1, Q2, Q3, Q4, Q5, Q6, right? You already have these values. So here from this matrix you can take 31, 32, 33. So this is about R3 formula. So you know all the values. You can substitute, you will get the R3 value like this. Suppose if you want R4, K41, Q1, 42, 43, 44, 45, 46. Here Q1, Q2, Q2 same. Like that you have to find out R4, R5, R6. This is about problem. Okay. Thank you.